Uh, I would like to thank the SSE for the honor of this Dinsdale Award and the honor of giving this lecture. When I learned that I had received the award, I thought carefully about what might be appropriate to talk about for this audience, and especially because it's a joint meeting with the SSE and the Parapsychological Association. I thought an appropriate topic might be to talk about my career and how I have interwoven statistics with parapsychology, and then how that's led me to think that all scientists should be taking the results in parapsychology, shorthand called Psi, seriously. So here's an outline of my talk. I'm going to start with just very briefly my academic background, and then my Psi-related background and activities, and then addressing scientists about Psi, and then the important part, how Psi actually could be affecting medical and other studies. I got my PhD in statistics at Penn State University, and I've spent my whole career as a professor at University of California, except for some visiting places I'll talk about in a minute. So first at Davis for 3/4 of my career, and then UC Irvine for the last 1/4. My main research area, the first one is actually not parapsychology, it's statistics education and literacy. And I've written a couple of textbooks on that and some papers. And then second, I would say, is statistical applications in parapsychology. And I did a little count, and about half of my research papers are on that topic. But I've also worked in applications of statistics to many other disciplines like transportation engineering, medical studies, and so on. And then I've written some papers with methodological advancements in statistics that go into statistics journals. Here's my Psi-related background. My very first sabbatical was right after I got tenure, and I went to Stanford. And just by coincidence, Peter Sturrock, who was one of the founders, probably would be considered the founder of SSE, was at Stanford. And so just by way of a conversation with somebody, I found out about him, and I found out about SSE. So I went over to see Peter, and since I was on sabbatical, I was free to travel. And so I went to the SSE meeting that year, which happened to be held in Princeton. And at that meeting, I met Hal Puthoff and Ed May, who were working on the remote viewing project known as Stargate over the years at SRI International. And they happened to be looking for a consulting statistician. So one thing led to another. And eventually, a few years later, I ended up spending a year at SRI International working in that program as a visiting scientist. I just want to make a little side note here. Stargate was just one of many code names that were used for that program, but it seems to be the one that people use to refer to it. So that's what I'm going to use as shorthand. I also had a visiting position at the University of Edinburgh, the Kessler Chair unit there. I was a visiting senior research fellow. So again, that was another sabbatical leave. And then another shorter one at IGPP in Freiburg, Germany. Some of my Psi-related activities, I'm going to talk a little bit more in detail about this, but I was one of the reviewers of the Stargate program report that went to Congress. And again, I'll talk more about that. I've given talks to many statistics departments and conferences explaining Psi research and results to statisticians. In the 90s, I was invited actually to publish an article in a journal called Statistical Science, which is a widely read review journal for statisticians. And I was invited to write an article on parapsychology and statistics, and there were some discussions accompanying it, so discussion papers accompanying it by some relatively famous statisticians. And so that got some attention. In 2016, I was president of the American Statistical Association, which is our largest professional organization for statisticians. And so, of course, I couldn't resist saying something about Psi in my presidential address for that. And in particular, I focused on how even statisticians tend to place belief over data when it comes to things like Psi. And then, as I mentioned, I've written some textbooks, and so I get to choose what examples go into those textbooks. And so I have several Psi examples in my textbooks. So those are my attempts to kind of get the word out. So let me talk more about the Stargate program and review. As many of you probably know, from the 1970s to 1995, the US government had a program focused on remote viewing, but the idea was to see if so-called psychic spying would actually work. And as I mentioned, Stargate was just one of the code names, but it's the one I'll use for shorthand. In 1995, the Cold War had ended, and so the DIA, the Defense Intelligence Agency, which had been hosting the program, didn't really want to keep it. And so there was a little bit of a political upheaval there, and parts of the program were declassified, and Congress asked for there to be a review of the program. And they hired a think tank called the American Institutes for Research, or AIR, to review the program. And there were two parts to the review. There was a review of the scientific research, and there was supposed to be a review of the so-called operational work, the psychic spying. Ray Hyman, who's a skeptic psychology professor, and I were hired to write the report on the scientific research. And AIR was supposed to write the report on the applications part, and they did partially, but we found out later that there were many, many boxes of material that they never even opened. Okay, so let me turn to the part that I worked on. This was the summer of 1995, and Ray and I were asked two questions: does psychic functioning work, and is it useful for intelligence work? We were sent 3 boxes of reports from the government work at SRI, and then later it moved to SAIC. We were told to focus only on the government program, but as a statistician, one of the hallmarks of science is replication. And so I said, no, I'm not going to do that, because all that work was done at 2 labs, but really by the same people. So Ed May was the director of the program at the time that it moved to SAIC, and he moved with it. He was the one that moved it there. So I said, I'm also going to include similar work that's being done in other laboratories, in particular the Gonsfeld work. So here's what I did. I used the sort of traditional statistical methods, p-values and confidence intervals, to see what the data showed. And I equated everything as if all the experiments were done with 4 choices to make it simple, to be on an even footing. So if you have a remote viewing and there's a target, then the judging is done by showing 4 choices and the response to a judge. The judge has to try to determine which of the 4 choices the judge has to decide whether which one of the targets, possible targets, the response matches best. And so by chance, the judge would choose the one that was actually the target 25% of the time. What I found was, for the SRI work, the correct target was chosen about 34% of the time. So in other words, the one that the judge said matched the response the best was actually the target about 1/3 of the time, 34% of the time. And in SAIC, very similar, about 35% of the time. And again, when you would expect 25% of the time by chance. And I calculated p-values and confidence intervals, and those were very, very statistically convincing. And as I said, I also thought we should look at something that would replicate remote viewing. And the closest thing at the time was the Gonsfeld studies that were being done. So I looked at all the different labs that were doing Gonsfeld studies, and I also included the early meta-analysis that had been done up to that point, but that had identified some flaws. And so it had I think, probably optimistically high hit rate, but the others all had very similar hit rates to the SRI and SAIC work. So again, 34, 37, et cetera, % So to me, that was very convincing evidence that we have something going on here, and that it's replicating over similar paradigms and across multiple laboratories in different countries with different researchers. And so here was my conclusion that I wrote in my report. Using the standards applied to any other area of science, and I should have said that uses statistics. I mean, I didn't mean like, chemistry. It's concluded that psychic functioning has been well established. And I based that conclusion on the p-values and confidence intervals, but also on having visited several of these laboratories and seen how good their controls were. I mean, frankly, I always tell people these experiments are some of the best experiments I've seen done in any field, because they have to be, to rule out having the skeptics throw them out. So I based my conclusion on all of that. But as you probably know, Congress decided to end the program anyway. But I don't think that was a scientific decision. That was more a political decision. All right, if you're interested in more about the Stargate program, Ed May and Sonali Marwaha have written 4 books that much of these books is, a lot of the book just is actual verbatim reports, so reprinted reports from SRI and SAIC. And you can see there are 2 on remote viewing, and 1 on psychokinesis, and 1 on the operational remote viewing, also called the psychic spying. So you can get those books now. They're all 4 available at this point. All right, so now let me turn to addressing scientists about psi. As I said, I've given many talks in statistics departments, and I've talked with people about what they think. And what I've discovered is that scientists, like others, tend to put more weight on belief than on data, especially for topics like psi. As much as they like to think that they're objective, they're not. And so one of the idea that I had was there's an area of statistics called Bayesian statistics or Bayesian statistical analysis, where you quantify your prior beliefs and then you combine those prior beliefs with the data and you update your beliefs based on how the data might alter them. And so I did a lot of talks with that approach as well. And what I like about it is that we can agree to disagree, because if we have different prior beliefs, we're going to get different it's called posterior beliefs in the end. But if someone's really an open-minded skeptic, the data should sway them to some extent. And that's where I would like to talk about, need to differentiate between skeptics who are unsure and debunkers. And those are the people whose prior belief is essentially 0. And so if you ask somebody for their prior probability, you can find out who the debunkers are and who the actual skeptics are. Most scientists actually have not seen the evidence, and I've noticed when I give these talks on it, they're quite intrigued actually when it's presented to them. And I think at that point they think, well, yeah, okay, well, that's nice. The effects aren't large. I'm not going to think about it. But I think you need to explain why they should care about it. And that's the focus of the rest of this talk. Okay, so I always like to show this slide. Testing your belief system. What would you do? So I don't know if many of you have seen the Ziggy cartoons, but here's a Ziggy cartoon. Mr. Ziggy, you've got the whole plane to yourself. The large group going to the psychic convention all canceled at the last moment. And so I asked people, all right, this is a true test of your belief. Would you get off the plane? If you would stay on the plane, your prior belief is probably 0. Okay, so I'm assuming most people know these terms, but I'm going to go through them just in case, because I know we have a mixed audience here. So I apologize for the outdated shorthand terms for these effects, but they're convenient and they're in this sort of general English language. So telepathy is the idea of mind-to-mind communication between people. Clairvoyance is the idea that people might know things without use of their 5 senses, even if no other person knows them. And precognition is the idea that you might know something from the future. And here's just little schematics for them. So telepathy, she's thinking about a glass of wine, and well, there could be other reasons why he is too, but telepathy would be the idea that he picks that up from her. Or you could have the glass of wine on the table, and clairvoyance would be that he picks up what's there. And then precognition is the idea that he thinks of this at 11 o'clock and it happens at 11:30. Okay, there are also studies that show the possibility that there might be remote healing might work, or what's called DMILS, distant mental interaction between living systems, that there might be some way that people can either influence or interact with the living system of another being. And then presentiment, this is the idea that Dean Radin and Daryl Bam and others have been working on, which is that people's physiology changes when something emotional is about to happen to them, even without conscious awareness. And then there's other ideas. So there's the idea of that maybe people can either influence or predict supposedly random sequences. So micro PK is the idea that they can influence them. DAT is a term Ed May came up with, decision augmentation theory, which is the idea that maybe you can get psi information about when something favorable is going to happen. Like if you make a decision in a certain way, it'll have the outcome you want. And a sort of small application of that is that if you're doing a randomization for a study, maybe you can hit the button to start randomizing at a favorable time. Here's a simplistic example. Suppose there's a random string of heads and tails. It's just moving along. Nobody, it's not, you're not saying when to start creating that string. And the idea would be, you generally, we don't think you can see what's coming, but maybe using psi, you can actually choose an arbitrary good time to start. So here's an example. So you've got a string just by random chance that happens to have 8 heads and 2 tails. And so you would push the button to start collecting your randomization string at that point. And that's the decision augmentation theory idea. And it doesn't matter which of those two it is. It's the idea is that maybe you can actually get a favorable random sequence. And there's lots of data to show these possible effects. Several meta-analyses with very strong statistical effects in the sense of tiny p-values, even if they might be relatively small effect sizes. Frankly, the evidence in parapsychology is stronger than in many areas of medicine and psychology and so on. I use the example when I give talks to statisticians of the data showing that aspirin might help prevent a future heart attack or stroke. And the Psi data is actually stronger than the data for that. So how do these results challenge medical studies? Well, let's go through some of the assumptions that are made when you design and analyze a clinical trial. First of all, we assume that it is possible to randomly assign participants to treatment groups. We assume it's possible to have double-blind studies. We assume the results of an experiment can't be known before it's conducted. And we assume that results are independent between unrelated people. So what happens to somebody in the Mayo Clinic shouldn't have anything to do with what happens to somebody taking that same drug in San Diego, let's say. But if the results of the research in parapsychology are real, some of these assumptions actually might be wrong. Okay, so let's look at how a simple drug versus placebo clinical trial works. Somebody enrolls in the study. They're randomly assigned to receive either the active drug or a placebo. And then after a period of time, a health outcome is measured on each person. And then those are compared for the two groups. And then the conclusion is that the drug works if the drug group does statistically better than the placebo group for that health outcome. All right, so here's some features of a good clinical trial, the way we currently understand them. The first one is the whole idea of having a placebo or a control group. And the idea there is that participants are treated the same as those receiving the active treatment, except they don't receive the active treatment. And why is that done? Well, because there are all kinds of other things that are going on in the background. You know, you have a pandemic that starts that's going to affect health outcomes. Well, that sort of thing. So you want everybody to be treated the same for everything else, except that one group's getting the drug and the other group is not. So that's why that's done. Okay, random assignment is another feature. And what is it? Well, the treatments are randomly assigned to the participants. Who gets which treatment? You know, the medical practitioner who's running the study doesn't say, oh, look, there's a guy that looks healthy, let's give him the drug, and so on. And again, the purpose is to balance out what are called confounding variables. So things like age, how much someone exercises, what their diet's like, their general health, and so on. So you want those to be approximately equal across the groups. And the idea is that if you use random assignment, that will in fact be what happens. All right, 3, blind or double blind. So what is it? Well, participants, and if possible, the evaluators are not told who's receiving which treatment. Double blind means neither group knows. Single blind means only one group, either one are blind. So for instance, if you were doing a study to see whether meditation lowers blood pressure, obviously the people who are meditating will know they're meditating, and the other group will know that they're not. But the person who measures their blood pressure should be blind to who's in which group. And why? Well, again, to avoid self-fulfilling prophecies, the expectations, and what we know exists, which are experimenter effects. If the experimenter interacts with the participant and the experimenter knows which treatment the participant has, they might treat them differently. Another feature is predetermined stopping rules. So you can't decide when to stop the study, because then the researcher could decide to stop it at an opportune time. There are ways to get around that. There are statistical designs that actually allow for early or interim results in stopping, but they have to be specified in advance, and that gets taken into account in the analysis. All right, well, let's look at how parapsychology might challenge all of this. And let's start with the design phase. So as I said, somebody walks in or whatever, they enroll in a clinical trial. So maybe they subconsciously know when to enroll so that they're going to get the more effective treatment. Or maybe the experimenter subconsciously knows how healthy someone is and randomizes so that the healthier participants get the treatment instead of the placebo. Or maybe the experimenter influences or predicts, as I said, micro PK or DAT, the randomization string to get the desired outcome. And I'm going to show you how that could work. So thanks to Ed May for this slide and the next one. I love how he creates these great graphics. So here's how we think it works in normal medical experiments. Okay. So you have your population. Here it's a population of lab rats. And you have your control group and your treatment group. And you use an unbiased randomization process, and you assign the participants to each of the groups. So one group, the control group, gets the placebo, the treatment group gets the drug. And then you compare their outcomes. And here you get a nice T statistic and a p-value of 0.02. And you think, aha, the drug worked. But now here's how it could be mimicked with Psi. Of course, natural populations are not homogeneous. So all populations have their fat and healthy and their sick and skinny. And so now you can have your two groups, but now suppose you use a Psi biased random process, then this is what could happen. So now you've got your placebo group with more sick and skinnies and your treatment group with more fat and healthies. And suppose the drug is just ineffective, just the same as the placebo, you could still see this as your result. So this is how Psi could interfere with a legitimate clinical trial and make it look like the drug worked. That's one way. All right. It could also be used to rule out double blind. So if anybody knows who's in the placebo group, then the participants might subconsciously use telepathy to find out and react the same as if they consciously knew. And there's a reason we don't consciously let them know, but maybe they could know. Or let's say nobody knows the randomization scheme, only a computer. They could still use clairvoyance to get that information. Or given that they're eventually going to be told which group they're in, that's part of what the ethics of a clinical trial, they could use precognition to know sooner. And so if they are subconsciously knowing which group they're in, they could communicate that to the evaluator and change the evaluation. Or they could react differently, given that they know that they're on the placebo or they're on the drug, just like they would if they knew consciously knew. So maybe double blind isn't possible either. And then we've got the healing phase of the study. So the researcher could subconsciously know who has which, the drug versus the placebo, and subconsciously use distant mental interaction to affect health, good or bad. The researcher could also know who's taking the drug and use the experimenter effect to activate natural self-healing in those participants. I mean, the experimenter effect, as I said, is a well-known phenomenon. We know it's real. Double blind is supposed to overcome it, but maybe that doesn't work. And then there's broader possibilities. Maybe there is such a thing as a connected group mind, and maybe everybody who's involved in the experiment wants it to come out a certain way. And so they use their whatever Psi happens to be there to make the whole experiment succeed or fail. Related to this is the idea that that person at the Mayo Clinic and the person in San Diego may not actually be independent, and yet our statistical models assume that they are. And certainly placebo research has shown that patient expectations can make a big difference in clinical trials. And so maybe there is this kind of group mind expectation. Research has also shown that even using normal methods, negative expectations can spread across individuals in a clinical trial. More possibilities. The effect of a drug may not remain constant over time. Maybe there's a group habituation effect that decreases the effectiveness of a drug over time for everybody. Also, research has shown that there is indeed inter-individual variation in placebo response. In other words, some people respond to placebos even though it's a placebo and other people don't. But maybe individual variation in Psi abilities is also out there. And so some people are going to have a Psi effect and others aren't. But our statistical models don't account for that kind of variation. So we may be using statistical models that are too simplistic for these clinical trials. And actually, that might help explain why we have a replication problem in science, psychology, and medicine. Because if all of these effects are coming into play, we already know, for example, that there are what we call Psi-conducive experimenters in Psi experiments. Maybe the same is true in other areas of research as well. And that would help explain the replication problem. So here's a summary of what could go wrong. It might be impossible to hide information, so you can't have blind or double blind experiments. It might be impossible to truly randomly assign participants to group. It might be impossible to separate the effects of a drug from the effects of someone knowing and healing themselves or having somebody else do distant healing on them. And so recommendations, first of all, the DAT part, if it's micro PK, that's different. But if it's a DAT part, if a randomization uses a new seed every time, so in other words, this, these randomization devices, you either set them to go and they go, or you could start each time, like every time a new participant enrolls, you restart the sequence. Then it would be harder to choose an advantageous sequence. You could use matched pairs or blocking so that you don't get all the fat and healthy rats in one group and the skinny ones in another. So you randomize people within a pair where the pairs have the same sort of health status. The good news for other researchers is that Psi effects tend to be small. And so if a trial actually shows a medium or large effect, it's unlikely that Psi is a major factor. And let's just review the consequences, though, for medical and other scientific experiments. I think we may need to rethink how we conduct clinical trials and other kinds of research to account for Psi effects. In the randomization phase, as I said, we need to use a new seed each time. Using matched pairs or blocking can get around some of these problems, even if there is Psi biased randomization. And again, the good news for science is if these effects are real, they're probably small. And so it's unlikely that Psi is a major factor if you see a strong clinical trial effect. But still, I think this is why all scientists need to be aware of the Psi results and to take them seriously. And as a textbook writer, I like to see that there's still a useful purpose for books. So, okay, and now we'll move on to the questions.